Hello, in today's video I'm going to talk about an amplifier manufacturer that I don't get a chance to talk about very much, and that's Magnatone or Magna Electronics. Later they were known as Esti by the late 60s. Early on in their life they were known as Dickerson. They were started by, I think, a guy named Dickerson. I think, and his brother also was an investor in that. I'll put a note up and clarify that. But this amp we have before us here is from 1950, and it is a Meany model. That's M-E-A-N-Y. The model number is M-197-3-M. I don't get a chance to talk about Magnatone very much because living in the middle of the country in Louisville, Kentucky, like I do, you don't see quite as many of them as you do Chicago-made or East Coast-made amplifiers. This one being a West Coast-made amplifier, and Magnatone was based in Los Angeles. I just don't get a chance to see very many of them. There aren't many hanging around in closets here in kind of the Bible Belt Midwest region. So this will give us an opportunity to take a look at a manufacturer we don't see very much. If this is something that you might be interested in, stick around. We're going to look at the outside of the cabinet. We're going to look at the inside guts of the amp. We'll take a look at the schematic. And by the end, we will also take a listen to it and see how it sounds. So stick around and we'll give her a listen. One thing I wanted to point out, actually, before we move on, you can see the remnants on the grill cloth here of a what looks like a crest of some sort. Now there would have been a lion on one side, probably, and a unicorn on the other. Magnatone made amplifiers for a couple of companies. One was named Aloha, and the other was called Noble. Noble was a Chicago-based accordion manufacturer, and accordions at the time actually had pickups installed in them, or microphones installed in them this early, and they were amplified. So, you know, accordion manufacturers also sold amplifiers. Magnatone was one of the suppliers for Noble. I have had a Don Noble amplifier before with this exact same crest on it, and I have seen examples of Aloha amplifiers with a very similar crest on it as well. Now most of it is worn off, but you can still see the remnants of it. But I just wanted to point that out. One other thing, you can see this kind of faux alligator leatherette covering that we see. There's actually, this is actually a woven fabric, and it looks like over the top of it there is some kind of enmeshed material in with the weave itself. Now that weave was beginning to come off in some places when I got this amp, most notably down here on this side corner. I've gotten this all glued back down and smoothed out as much as I could. There were some other areas here where it was completely peeling up as well. I've gotten that smoothed back down and glued in nicely. Down here on the back, and you can see our 3-prong cord, and we'll discuss that a little more later. But this is the back of the amp, and all of this down on the bottom was peeling up. It looked like maybe at one time, I don't know, this may have been stored in not so ideal conditions, and all this on the bottom had peeled up, and it was pretty filthy inside as well, so I cleaned all that out and just generally gave the amp a once over and a spruce up. The faceplate is still in pretty good nick. We do have a few paint chips here and there, but overall it looks pretty good for its age. To be, you know, over 60 years old. It's doing pretty well. But yeah, let's open this thing up, take a look at the guts of the amp, and see what needs to be done, and we'll discuss some changes that were made. I was not able to find a schematic for this amp, but I will show one that I've drawn, and that'll give us a better idea of what we're looking at here. Okay, here's the inside of this little Magnatone Meany amp, and Back here is the can capacitor that we've bypassed. There were actually 3 caps inside this can. One of them was a bypass cap for the 6v6. I have replaced that one here. And there were 2 20 microfarad caps, which I've replaced here with some Nichicon. The amp is dated 1950, and I know that because the pot for the volume has a 1950 date code on it. Wasn't able to find really anything else with a date code. The output transformer has a code of 1623, and I'm not even sure what that is. It's some esoteric number. And then there's also like it looks like a 1491 number on there as well. Not sure what those are, so can't really date that from that. Maybe that'll mean something to someone else though. This amp has had little Sangamo caps, and you see these in a lot of older equipment from the 50s. I've seen them in a few organs and things from around this time period as well, and I believe Dan Electro also may have used these caps some, and you see those some in Dan Electros. Here's another cap. Here's that one from the input. There's another one tucked underneath here, and this one's original as well, but this one's a paper one. Or actually I may be mistaken about that being paper, but anyway, there's another one tucked under there. Not much was done to it other than the caps. I did change this resistor with a pair of resistors to get a 1 meg value in this position. The one that was here was a bit iffy, and that was a power resistor, so I just went ahead and replaced it. Seemed to be jumping around a lot when I measured it, so it's just better to be safe and go ahead and replace that. So that's been replaced. We have the 3-prong cord. I've grounded it to this position. This is where the death cap was, and here is that cap. And this is also indicative of the other caps that are in the amp, so you can kind of get an idea of what they are. Again, Sangamo USA, type 30, and there's the value, 0.05 at 600 volts. But that was in this position here, and that was your death cap that has been clipped out. So I've grounded our 3-prong there. Our black lead is going first to the switch. Nothing else really to report. There was one little tear in the cone of the speaker, and it looked like somebody may have cranked down a little hard on these lugs at one point and slightly warped the speaker. And I've kind of bent that back into shape as much as I could, and went ahead and repaired this with just a dab of hot glue on the other side and spread it out really thinly. And I don't think that's going to be an issue henceforth. And the speaker does sound pretty good now, so I'm going to leave this in. This is the original speaker, I believe, so we'll go ahead and leave this in for the next owner so you can have the original speaker. At some stage, if you wanted to replace that, you could probably get a lot more tone and volume out of the amp by going with something just a bit more modern, and then breaking it in over time. And then you could also come back, like I've shown in the schematic, or like I will show in the schematic, and you could add a bypass capacitor and resistor to bias that 6SJ7. That'll beef things up quite a bit as well. But here we'll look at the other side of the chassis and see the. Well, first of all, here's the face plate, and we can see Magna Electronics, Los Angeles, California. Here's our fuse. Here's our indicator light. This was burned when I got it, so I'll replace that. This is the original Chickenhead knob by the look of it. The other ones I've seen online have the same knob. I believe these might even be all original tubes. This is still the metal variety 6v6. This is our 5Y3, and it has a code on it as well of 322-030, so that's the 30th week of 1950 also. Over here we have the number M197. You can't see it, but that should be a 3-M. So that's our model number for our schematic, which again we weren't able to find. Went ahead and loosened both these jacks and cleaned those because that's how they're grounded. So cleaned all that. Cleaned our we cleaned our sockets. Yeah, pretty straightforward. We have here's a code on this transformer as well, 6308. Yeah, everything fairly straightforward. You may be wondering about the wires appearing to come out of here. This is actually a really heavy-duty cable, and this shouldn't be an issue. This retainer, I wanted to reuse the original retainer here. I try to reuse parts as much as I can. Reuse the original retainer, and it was a little too small for the entire cable, so I'm retaining it with the 3 cables. And there's a retainer here on the sidewall anyway, so this isn't any danger of ever pulling out. So just to let you know before somebody yells at me about that. When I got this cab, it was actually some of this red covering was coming off of it, and I'll show that in another portion of the video as well. But I've actually fixed a lot of that, and probably did more cosmetic repair than even internal repair. So let's take a look at a couple other things, and then we'll get a listen to the amp. Okay, here's the schematic for the amp. Again, this is a model M-197-3-M. The example I have is from 1950, and the example I had was all original, so these should be the original values for everything. I was not able to find this exact schematic anywhere online, so I've had to draw it. But what we could see here, there was a schematic that actually was close, and I'll show you that one. This schematic I found was close, but no cigar. It's a this is a Dickerson mother of toilet seat lap steel from 1946. This is another text notes from, I guess, something he had done. But we can see here the input resistors are different. There are some different values throughout. It's very similar, and actually I just drew the schematic that I had kind of based on this one. There are some differences though. We'll see here the first node of the power rail goes to nothing. There's a 10 microfarad capacitor to ground, filter capacitor, and there's nothing coming off of it. It doesn't do anything, in fact, until it gets over here, and all of the tubes are fed off of this one node over here. So that's different than any of the fenders or anything like that, even that are similar in design. So that's the major difference. And if we look at the power rail, we'll switch back here. If we compare the two power rails together, we can see the differences. Here we have 20 microfarad caps in the amp that we actually have. There's a 1K resistor before the first node, and then there's a 20K dropping a resistor after that first node into the second node. Now the first node, of course, powers our 6v6 plate. The second node is powering the second grid of the 6v6, and it's also coming over here and powering our grid and our plate of the 6SJ7 pentode. Another thing is in this one we see that it doesn't show the center tap doing anything at all, and actually the tech here had a note about that the 6-volt center tap wasn't used in this Dickerson at all. I guess they didn't even ground it. It was there, but it wasn't grounded anything. In the amp that I have, the center tap for that 6.3 volt went to pin 8 of the 6v6, which is the cathode. So that'll be actually a little lower than potential than ground. It'd be a negative potential, so there should be even less hum when tied to that point than if tied to to the chassis. And in fact, this is a very, very quiet amp after I've done all the servicing. Speaking of servicing, there are some things I could have done probably to beef up the tone on this, but I wanted to just go ahead and keep it original because the thing sounds so good, and we'll get to that in a bit. But we'll notice here that there is no cathode resistor or bypass capacitor on the 6SJ7. In our Dickerson mother of toilet seat from 1946, we see a 100 ohm resistor and a 10 microfarad bypass cap. That's going to beef up the signal considerably coming out of here. Now, probably what they've decided to do, now they beefed up the signal here on this design, but they in essence weaken the signal by not using this node here. So kind of a trade-off that they've done in the design that I have. They've taken away that resistor and capacitor and just gone straight to ground, and over here they've actually used this node, so it's kind of a trade-off. I'm not sure. This one probably is still a little more powerful, this considered, so I'd say this is the better design. And even if you wanted to beef it up and get a nicer speaker in this amp, now the one that's in it is the original one. There is a little tear in the cone that I've repaired, but you know, it's something, if you put a modern speaker with more power handling in the thing, it would probably make it a lot louder. And if you wanted to make it beefier still and louder still, you could even add a resistor and you know, a 25 or so microfarad bypass cap, or even a 10 like they had on the Dickerson here would beef up the tone considerably. Some of the other values that are changed, we can see the inputs once again. Here in this design we have 100K, here we have 120K, we have a 0.01 cap, here we have a 0.005 cap, here we have a 500K resistor to ground, but here we have a 10 meg resistor to ground. This is gonna be more resistance to ground, and the signal that we're feeding in from our guitar is going to find a really unappealing path to ground here. So more of the signal is actually going to get to this first tube and thus get amplified. So that's beefing up this version much more as well. So so that's an improvement. One of the other things, this was a 20 microfarad, and it was actually inside of the can cap, the cap can rather. This 20 was. Here on this design, we see a 10, so, and a 390 ohm resistor. 390 ohm is pretty standard for most 6v6. 250 is not outside the realm either. But these are overall, this design is very similar to other simple amplifier designs of the period. It's similar to some of the earlier Fender Champs. It's similar to some of the Dan Electro Silvertone made stuff. This guy actually here has a note that says it's similar to Airline 79A or Silvertone 1301. Not sure how true that is, but I suppose you could look that up if you want. Let's see. Yeah, that's about all there is to report. Now, of course, I'm adding a 3-prong switch, excuse me, a 3-prong plug as opposed to the 2-prong, and also getting rid of the death cap, so this won't be in after the service. But all in all, it should be very similar. Now, you know, 20 is not the value I use. I use 22, but those are really close. So that's it will be virtually the same as it would have been new, minus some of the drifted values. Now there is one other thing to cut down, and this is one tip that you can also do to kind of cut down on some of the some hum if you have any in your designs. Now this probably wasn't even necessary in this amp. I find it to be extremely quiet at idle after I've done the cap job. But you can see here across the leads on the 6v6, here's the plate coming out across this output transformer leads on the primary. We have a 0.01 600 volt cap. That's going to cut down on hum. Here in this design, it's a little simpler, and we did not have that cap. Also, there's a 500 ohm resistor here, and they did that to step down and feed this 6v6 plate. Now we don't have that here, and actually when I was copying this, I kind of accidentally drew that in and it wasn't there, so I got rid of that. So that's a difference. So yeah, overall they are very similar, but there are some key differences that make this really its own amp, and hopefully this will help somebody in the future. I don't know if you have one of these old Magna Electronics Meany M-197-3-M. Here's your schematic that I could not find. So hopefully that helps somebody. Let's move along and listen to some of the tones of the amp, and I think you'll see what I mean when I say this is a pretty awesome sounding little guy. Okay, we're going to take a listen to this thing now, and for the purpose of the tone demo portion, we're going to use the 1978 Fender Walnut Stratocaster, and we'll see what kind of tones we can get. Helps if you tune before the video, but that is a 1950 Magna Electronics model, a Meany model.